Hello,
Hi there, Rhea. How are you doing?
I'm good. How are you?
I'm good, and thank you for being so understanding. Today was just hectically crazy, to say the least. Um, so yeah, I started a bit late. The student got caught in traffic, so I'm sorry that then dominoed, but I did try and ensure to let them know that I've got a year 13 student with exams, so we need to try and finish sharpishly. So hopefully we shouldn't have this problem next time. Yes,
Mhm.
so we have missed also one lesson, I know. How have you been keeping and how's the revision going? Just as a little bit of a check-in.
Stressful.
Oh, I can imagine, I can imagine, I can imagine. Okay, so just to put some things in perspective, okay? This is one thing I wish I was told enough when I was preparing for my exams, and that is it's not really that it's about working hard, it's about working joyfully. Okay. Now I know it seems very difficult to almost grasp as a concept to enjoy getting ready for exams, but unless you somehow find that it puts the brain under unnecessary stress. Okay. So
Yeah.
it's okay, firstly, to make mistakes and to laugh at yourself and say, wow, okay, it's okay not to understand something as well. Okay. And also have full trust that you have a mind that is capable of doing so much. And the school system is just one way that's exercising it in a certain sense. So just because something seems a bit incomprehensible, that just presents an opportunity to then view or find other ways in which how your brain best operates when you're looking at that problem. Okay. So I know it's it can be very stressful. And one of the things that we don't do enough as teachers and schools is we don't teach there's no subject that teaches you how to cope with things like the stress that exams pressure bring. And if there was any such subject, well, then we wouldn't have hospital beds so full of people who are suffering from stress because they would have been taught that skill from very
Yeah.
early. Okay. So I know it's very difficult, but one of the things I went through, which is extremely stressful, was doing a master's degree. When after I'd finished my first degrees at Cambridge, to go and do a master's degree was one of the most extremely stressful things I've done. And my supervisor told me something. He said, see this as an exercise in learning how to manage stress, but also learning how your mind works. And I learned a lot from that. Okay. So
Mhm.
these are some of the things I'm imparting to you to say, as best as possible, don't be angry with yourself if you miss a point. If you do it joyfully, your mind will remember a lot more and you will not be creating an enemy of your own for your own self. Because otherwise you become your own enemy if you begin to blow things out of proportion more than what they are. So please, as best as you can. I know it's really difficult, but as best as you can, try and do it joyfully. Okay. Have fun with it. All right. It'll be much
Mm.
better if you do it that way. Okay.
Yeah.
Excellent. Okay. Away from the philosophy now to, okay, problem solving. So I took note of what you said, and what I decided to do was pick some questions from areas we have not quite done any questions from as such. So I thought throw in a few questions. So we haven't done things like coordinate geometry on circles, even though that's
Mhm.
on the advanced information. And I know that that was not tested in your recent test either. So you've not had time to look at it, but it is in the spec. So we're going to do some questions anyway along those lines. Do you know when you might receive results for your test?
I'm not sure.
You're not sure. Okay, that's fine. No problem. Okay. So when you're ready then, Rhea, do you want to have a go at the first question? Let
Mm.
me just adjust my pen here. Oops.
Do you take the k squared to the left-hand side?
Absolutely spot on. Well done. Good start.
Mm. When it says two distinct real roots,
Yes.
doesn't it mean b squared minus 4ac is bigger than 0?
Very good. Excellent.
So then...
And this here is what we call the discriminant, isn't it?
Yeah.
Good.
So is b is minus 4, right?
Well done. Good.
And then a would be k squared. And would c be 5 minus k squared?
C minus C is equal to 5 minus k squared. Excellent. And A would be k squared. Very good. Keep going.
So then you do minus 4 squared minus 4 times k squared times 5 minus k squared
Good.
is bigger than 0. Minus 4 squared is 16. Minus 4k squared. Oh wait. Minus 4k to the power 4.
Well done. That's absolutely spot on.
Add 20k squared. Or something like that. Could you divide it all by 4?
Spot on.
So you'd get 4 minus k to the power 4 plus 5k squared is bigger than 0.
Now, just be very careful on your sign there, okay? So we know we're plugging it into here, so just take extra caution. So this here, of course, would be, if we plug things directly, minus 4 squared minus 4 multiplied by A, yeah? And this is also multiplied by C.
Yeah.
So be careful in expanding this.
So you'd get 5k squared in the bracket, 5k squared minus k to the power 4?
So when you break, so you get 16 minus. So minus 4k squared times 5 is minus 20k squared. Minus 4k squared times minus k squared, you would get plus 4k to the 4. Is this what you've got?
I've got the signs the wrong way around.
This is, yeah, not to worry. So just be careful. This is a negative and it's times into something that is a negative. So I need a positive. Negative again, multiplying to a positive over should be a negative. Okay.
Okay.
And then we're saying that this here must be greater than 0.
Could you factorize it?
Yeah, which is what you did now. Now, at least hopefully the factorization should be spot on. So what did you get here when you factorize it? You've got 4 minus 5k squared plus k to the 4.
Yeah.
That's fine. Yeah. Good.
You can't take k squared out, can you? Can you take k squared out?
No, not quite. You can't on this one.
Or do you just plug it in the calculator?
Good point, good point, good point. Now, a little bit of a hint here. Again, this is something sometimes that I know is tricky for you to spot, but can you see a little bit of a hint? Can you see a hidden quadratic?
Oh, it's the, like when you let y is equal to k squared.
Very good.
So it's like a quad. Oh, right, okay. So you could let k squared equal to y. So then
Very
it'll be
good. Very good. So you're right. So
minus.
let k squared equals 2y. I like it. Keep going.
So then it would be 4 minus 5y plus y squared is bigger than 0.
Correct. Good.
And then you'd factorize that.
Good.
So you'd get brackets y plus 1 and y plus 4 is bigger than 0.
Now you're nearly there. Now remember, this is minus 5.
Yeah.
In other words, that's minus 5. So if you're going to factorize this, you're looking for two terms that add to give minus 5, but multiply to give positive 4. If you're looking for two brackets, the multiply to give positive 4, but these two terms add to give negative 5.
So it's minus 1 and minus 4.
Very good.
And then, so that means y is equal to, wait, y is 1 and
Y is 1 or y is what number?
4.
Very good.
So then doesn't that mean, so that y is k squared, so then k squared is 1.
Good. So what's the value of k?
So you'd square root it.
Yeah.
So it's just root 1.
Yeah, but remember,
Plus
whenever you, very good, excellent, Rare, very good. So we say that k is equal to plus minus 1, or k is equal to what value?
plus minus 2.
Correct.
And then do you have to write it as an, oh no, you don't, I don't think.
It has to be. It has to be written as an inequality. It
Yeah.
must be greater than 0. So this k here, you've just solved this equation by, you made this equal to 0 when you solved it.
Yeah.
But you know that the real sign you need is the inequality sign. So we're going to need an inequality sign. So how are we going to deal with this now and drop it into an inequality sign? What's the easiest thing to do with such? Hint, sketch. It's the only way. If ever you're solving a quadratic inequality, sketch it. You will go wrong otherwise. Okay.
That's what I usually do.
Very good. I do that every time, even today. Some people do it in their heads, and I just think it's wrong, and you're inviting errors. Yeah.
Okay,
so even the best
to
mathematicians I know. Yeah, it's easy, and you can see it as well. So you're not overloading your brain unnecessarily. Okay. So sketch.
So it would be at 1. Wait, so won't you get 4 roots?
Very good. Now, we know that very, very good. You would get 4 roots. Spot on, spot on. Now, just a reminder, we know that for y equals x squared, what does the graph look like? Or quadratic, it would look like this, smiley or sad face. Let's say a positive quadratic. Yeah. So this is y equals x squared. Yeah. Can be drawn like this as well. They're all general shapes for something that is a function of x which is related to a quadratic.
Yeah.
What about if now you had something that was to the power of 4? So what would y equals, I don't know, x to the 4 plus 3x cubed plus, we can go on. What might that look like?
Would it be similar to a quadratic?
Very similar. They're all even functions, aren't they?
Yeah.
Because that's to the power of 4, that's to the power of 2. They're all even functions. But because it's to the power of 4, this means it's got 4 roots. This here has 2 roots. And if it was a cubic, the 3 means there'll be 3 roots.
Oh, yeah.
Okay? So the
Yeah.
highest order tells you how many roots it's going to have. So just as a bit of a hint to help you out, this will do something like this.
Okay.
And these will be the roots.
Are we supposed to? I've never got taught this graph in class though. Do we still need to like know it?
Yes, absolutely. Matter of fact, y equals x to the 4 does not look different to y equals x squared. It's just wider. It's got a bigger bucket.
Yeah.
But when you add other terms, that's when it starts cutting into the x-axis. So it's worth knowing this.
Okay.
Okay.
If it's greater than 0, doesn't it mean it's like bigger? So it's like going outwards.
It's all the positives, yeah. So everything in this region.
Yeah.
Good.
So k would be between -1 and 1.
Very good. So this here would be 1, and this would be -1.
And then it would also be bigger than 2 and -2.
Here we've got 2, and we've got -2 there. Correct?
So like, could you write it as 2 inequalities?
Yeah.
So then like k is bigger than -1, but smaller than 1. Is it equal to?
No, you've absolutely got it spot on there. So you've said that k is less than 1.
Yeah.
Yeah. But it is bigger than -1. Because bigger than -1 is that side there. Yeah.
Yeah.
Spot on. So that's one inequality. What about the other inequality for these portions?
So it's bigger than -2 and 2. Wait, no, it's smaller than, so it'll be -2 is, wait, k is big, wait, no, won't be bigger. Won't it be less than -2?
It would have to be less. You're spot on. Well done, Ryan.
But then it'll be bigger than 2.
Correct. Now there's a value of k we need to exclude. Which value is that one?
Oh, because it's real roots.
Hmm?
Wait, no. Is it the negative?
Not quite. There's one value of k you can't use in here, and that is k cannot be equal to 0.
Oh.
Because if you make k 0, this is going to be 0 on this side. This is going to go to 0. So you have -4x plus 5 equals to 0.
Oh.
Now this here is not a quadratic.
Okay.
So this value here would have to exclude. The main marks are from finding these values of k, but it would be worthwhile to make the point that k cannot be equal to 0. But well done. Really, really challenging this one. Okay. You've done the right things. Excellent. Okay. Next one here. Some transformations.
Yeah. Okay. Do you start by sketching them? That's what I do.
All the time, and that's good practice. That is just good practice. If you can do a sketch, sketch it. Good.
So the first one is where like f of x is equal to y plus 3. That's the graph, isn't it? For f of x.
Give the equation of the asymptotes.
Is it like, do you plug in the y in?
Yeah, so just think about this, what happens then, because it's the equation of the asymptotes we want to think about. So if we draw the sketch just for f of x and show where the asymptotes are, for y equals to -3, where will that line be?
It would be like when it crosses -3, like it'll be like a horizontal.
Very good, absolutely spot on. So that's the first asymptote. I should have drawn it dashed really. And the other asymptote is at x equals to 2. So this here is y equals to -3. Yeah.
Yeah, and then x is equal to 2 would be vertical at 2.
Very good, absolutely. And it would be a 2, wouldn't it? So some value 2. We don't know whether the function is in here or whether it's in here or there or there. We don't know, but that doesn't matter. Okay, that really does not matter. But at least we've got our asymptotes as our starting point. So what next?
So it says, give the equations of the asymptotes for the curves.
So hint, this here, it's best to rearrange this so that it looks like y equals f of x -3. Now it looks in a form that you're familiar with.
Oh, okay. It's like a transformation.
Yeah, and actually it is a transformation, you're right.
Oh,
but what kind of transformation? Is it a translation?
Yeah,
Is it
it's
a shrink?
translation.
Very good, excellent.
Does it go down?
It goes down, yes. And to what value?
-6.
Yeah, well done. Cool. So there it is. So the equation of the y asymptote would be y equals -6. What about the x? Anything?
No.
Correct. So, and x equals 2, because it doesn't affect, it's just a movement up and down. Well done, excellent. Part 2.
Okay, x. Okay, it's a translation again. Does it go right?
So this here was a vertical translation. Good, this is a translation. What kind of translation is it?
It goes right by 2.
So it's a horizontal.
Yeah, horizontal.
Translation, good stuff. Okay, so give me the equations.
X is 4.
X is indeed 4, good. And y?
It just stays the same.
Very good. Spot on, well done, Ray.
Oh, I forgot to mention. Next lesson.
Yeah.
Could we go through some trig?
Yes.
Trig questions.
Yeah.
I tried
So,
doing some.
Trig, do you want to go through, because there's quite a few aspects on these here. Of course, there's the identities.
Yeah.
Identities. Okay. There is differentiation and integration, and then there is modeling, application / modeling.
What's the application of modeling?
Application and modeling is literally where you're given a scenario which involves using trig functions. So it's just a scenario that involves trig functions, and this can fall under mechanics. Oops, mechanics or pure. So for example, okay, I'll go a bit ahead here then, just to give you an example of what I mean by this. So here you see, this is in the mechanics.
Okay.
Yeah.
Oh, it's like when you like integrate it on different
Yeah, this is variable acceleration.
yeah.
Yeah, so
Probably
this
need to go
here,
over it.
yeah, no problem. Okay, cool. All right, where are we? There we are. Okay, good. So very good here, but I will keep this in mind. But I think you probably, so that's the kind of modeling I was talking about anyway. Yeah.
Yeah.
So you might want to go through, what would you prefer to go through, like identities and stuff like that, and solving
I
them?
forgot what it said in the advanced information about trig.
Uh,
I'm pretty sure it's on all papers though. So
okay, let me have a look to see what it says on trig. Let's just have a quick look here. That. Okay, now I find there. Newton Raphson. Transformations, modules, arithmetic. Oh, inverse and reciprocal trig ratios, identities, and equations.
lovely.
That's what it says. Inverse, yeah, that's what it says. Yeah. Inverse and reciprocal. Under the mechanics, it talks about kinematics in 2 dimensions using vectors and variable acceleration and such. Yeah,
So it's like
okay.
modeling, right?
Yeah, that's like modeling, exactly.
Yeah.
That's under modeling,
It's
correct.
like those kind of questions as well.
Okay, cool. Now we're gonna go through that. So let's have a look here where we at. Good, we can do that, not a problem. Super duper. Okay, some binomial, your favorite, Rare. What is your favorite?
I don't know. I
You
don't
don't
think
know
it's
yet.
none of it.
Well, in these lessons, I definitely don't want to be giving you your favorite because you're going to be good at it anyway. So we don't want to be focusing on things that you're already good at. Okay.
Okay.
Okay, cool. All right. So have a go at the binomial. When last did you do some work on binomial expansion?
So do you expand the first bracket?
Good move. Very good move.
So it's like, is it
So just as a bit
the
of
one in?
a starter, yeah. So of course you'll be given this in your data sheet.
Yeah, because
1
it's like one, right?
plus nx, yeah, good. And n minus 1 x squared over 2 factorial plus n. You gotta know the gist of this, don't you? Yeah.
Yeah.
N minus r plus 1 over r factorial multiplied by x to the power of r. Now, there's different forms that this is given in anyway, but this is just one form I'm giving it. You can also write it in terms of combinatorial functions, but this is just one form you could use. They're all the same.
So it's, so for the first bracket, would it be 1 plus x plus
Now, the only way you can use this is that if you're going to expand it, I'll give you a bit of a reminder here. If you're going to use this here, it needs to look like this. So for instance,
do we not need to do the first one?
oh no, this is only affected by that.
Oh, okay, never mind.
Yeah, that's fine. Okay, so take note in your exam, unless if they put everything in brackets like this, then everything is affected.
Oh, okay.
Here, they have not. So mathematically, grammatically speaking, it's only this that is affected.
So you take
Bless
9
you.
out.
Sorry?
You take 9 out the bracket.
You
Because
have to,
1.
very good.
You'd need 1, right? So 1/9 inside the bracket.
No, you
wait.
wouldn't take it out like that. So you'd factorize it.
Yeah.
Okay, just to give you a hand if you have not done these in a long time. So you'd factorize this. So you'd put a 9 on the outside and then a 1 plus. Because you've divided by 9 to get a 1 here, you need to divide this by 9. Does that make sense? And please note that here you're dividing by, what 9 are you really dividing by? You're dividing by 9 to the power of minus half. It's a nasty question, sorry. You're dividing by 9 to the power of minus half. It's the only way you can take it out. Make sense?
Yeah.
So now you have 1 plus 3x over 9. And all this is to the power of minus half.
Oh.
Make sense? So now
Yeah.
you can expand this part here. Because it looks like 1 plus x to the power of n.
Yeah, makes sense.
Good.
It's 1 plus that bit, the 1 plus.
And of course, we can simplify this part here, can't we? Because 3 into 9 is 3. So we've got 9 to the minus of a half. Well, 9 to the power of minus half is what?
I don't know.
Not to worry. So,
wait, is it 9 squared is 3?
Yeah, so
wait.
9. Well, let's just say what is 9 to the power of a half?
I don't know.
That's okay. So I'm going to give you a little bit of a reminder here how you do this then, yes? So
is it square
9.
root?
Yay! Nice one.
Is it just 3?
To the power of 9, absolutely. So it would be 3. What about 9 to the power of minus half? What would that be?
It's like a reciprocal.
Very good. So that would be 1/3. Excellent.
Oh, yeah.
You're spot on. Well done. So that will be 1/3 multiplying by 1 plus x over, what do we have now? Over 3 to the power of minus a half. So now all you need to do is focus on expanding this guy.
Oh.
Because the third is just on the outside. You can always multiply that after. Okay?
Oh.
Did you follow that okay?
Yeah. Wait, how did you get x over 3?
So we had 3x. So we divided everything by 9.
Yeah, I get that bit.
Yeah. So 3 into 3 is 1. 3 into 9 is 3. So I get x over 3. Does that make sense?
Wait, 3, huh?
Okay, so I divided everything by 9 because I'm trying to get this to look like this here. So I wanted to have a 1 at the front. So if I divide everything by 9, so 3x divided by 9, this simplifies to x.
Oh, never mind.
You got it?
Yeah.
Good.
Oh, okay.
Good.
But like, you know how you got, like, so then you replace the 9 to the power minus a half
Yeah.
to 1/3.
Yeah.
Right?
Yeah.
So the power, like, on the right hand side, the power to, does it say -1/3?
This one here.
No, on the right hand side. After the
Oh,
bracket.
sorry. This side.
Yeah, after that on the top. To
Yeah,
the
this
power
is
of
minus a half.
Oh, a half. Oh, it looks like a 3. So
Oh, sorry, it's still that half. Good for
okay.
asking there. It's still a half. We're still using that power there.
Okay, makes sense. Okay, if I
Good.
expand this bit now,
Yeah.
you'd get 1 plus wait, no, minus a half x.
So what is your n in this case? Your n here is minus half.
Yeah.
And this value of x here is now x over 3. Yeah.
Oh, do you have to? Oh. Oh. But then don't you need the x? Oh, never mind.
Yes, but the x now, you're going to treat it with the whole x over 3.
So minus a 6 x.
So if we just expand this red, it's been probably a while since you did binomial expansion, isn't it?
Yeah.
Just as well, we're looking through it, not to worry. So we're going to get a third. Let's keep the third outside. And then let's just deal with expanding this thing here. So if I use this formula, I get 1 plus my n is minus a half. And x is x over 3. It's following so far?
Yeah.
Plus my n is minus a half. I'm here now.
Yeah.
And minus a half minus 1 is minus 3 over 2. And x squared, my x is x over 3. Over 2 factorial, which is just 2 times 1. So it's just 2. I don't need to worry about the other terms because it says expanding only to x squared.
Oh, the reason why I'm confused is because when I was doing questions on it,
Yeah.
the x, like I don't know why, but they never like substituted the x into the like equation so that you get x and x squared. I don't know why. I don't know if the questions were quite wrong. Probably were.
Do you wanna send me a WhatsApp of the picture? By the way, I'll give you my number again. Just it's much easier sometimes. 07459338486. Drop me a little line or send me a picture on WhatsApp or something of the question you were looking at. Okay.
Yeah, if I find it, it's been a while.
Okay. I know. Always used to happen to me. Matter of fact, I was so bad when I was revising for my exams because there were papers all over the room.
Yeah.
And then I'll be like, oh, where's that paper? Where's that paper? And you just couldn't find it. And then when you finish your exam, suddenly you find them. So
Yeah, it's one
one of
of the
the,
homeworks that I've done ages ago. I remember looking at the mark scheme, and it's usually the teacher writes it out,
oh, I see.
and then I don't know what they did. They probably did it wrong.
Oh, I see. Yeah. Worth double checking anyway. If you can find it, I'd very much happily look at it. So are you
Yeah.
okay then with what we've done? We've followed this formula strictly, but because we're only going to x squared, hey, I'm not bothered about the other terms because the other terms go into x cubed and such.
Yeah.
So far, so good.
Yeah.
So now if I simplify this and there's a third outside, do you want to have a go at simplifying this guy here?
Okay. So a third minus 1 over 18x. Is that even right? I don't know.
You're on the money. On the money. Good. Next term.
Hold on. plus 1/24 x squared. Oh wait, no, I've not times it by
Take your time. So we have got this
1/72
1/72.
x squared.
Let's just look at this part then, just see what your calculator is giving you. So minus half times minus 3/2. This is going to give me a positive result, surely. Yeah. And this is going to give me 3/4. Do you follow?
Yep.
This part. This here is going to give me x squared over 9. Because 3 squared, you have to square the top and the bottom.
Yeah.
You following? So this gives me 3x. Well, I can even simplify it. 3 goes into 9 3 times. So I get x squared over 12. Are you following?
Yeah.
Yeah. And then I divide this by 2, meaning I multiply it by a half. So I get x squared over 24. Yeah?
Yeah.
Very good. So this part here now is x squared over 24, but then I need to multiply it by a third, don't I?
Yeah.
I need to multiply it by a third. Very good. And if I multiply this by a third, what is 24 times 3?
72.
72. So I get plus x squared over 72.
Yeah, that's what I said.
Oh, sorry, I must have misheard you then. I'm so sorry, Ray. I'm so sorry. No, so you're absolutely spot on. Very good. So x squared plus 72. Don't care about the other terms. Excellent. Spot on. On the money. What
Then
next do we
you
do
have
now,
to you have to times it by 1 minus a half x.
Very good. So now I'm going to times this thing here using 1 minus a half x. Spot on. Multiplied by a third minus x over 18 plus x squared over 72. Now, here it's always worth picking out and realizing a few things. Well, if I times this, power of x to x squared, this is going to give me an x cubed. So I'm not going to bother timesing the half with this. I definitely won't bother. I will, however, bother timesing the half x by that term and that term. I will also bother timesing the one with all 3 terms and then simplifying it. Are we okay with that? Because this is an x squared term.
Oh, because you don't need it up to x past
I don't
x.
need it up to x cubed. If I multiply x and x squared, it's going to give me x cubed. That's the reason why I gave that an x.
Okay. Yeah, that makes sense.
That makes sense. Good. Okay, so what do you get when you simplify that?
Well, do you have to do it?
No, you don't. You really don't. Sometimes I wake up in the morning, I go, do I really have to go to work? Yes, I do. Okay. Okay, there we go. Okay, so this now is some functions. I'll leave this as a piece of homework because you've already done a binomial expansion question, and this will put you through the paces as well. Okay. Number 5, some circle stuff, hey?
Okay, got a point A and B are the 2 endpoints of the diameter AB of a circle. Find the equation of the circle in the form. Oh my god.
Sorry.
Okay.
Another recipe for a nightmare on Wednesday.
Well, could you plot the 2 points? I don't know if you know.
Yeah, I'll definitely do a sketch, Ray. I'll definitely do a sketch. Like
Well, like
that's
the 2 endpoints, right, of a diameter. So you could
yeah. So
find the
what does that
radius.
mean?
Wait. So that means that, like, on a circle, it'd be like at the 2 ends,
Yeah,
like a straight
correct.
line.
Yeah, you're absolutely right. So if this is the most perfect circle, but you know what I mean. There we go. So if that's the center of the circle, that's the diameter. Those 2 points would be at the end. Well, I don't know where A would be, but it's a sketch. Yeah,
Yeah.
is all I'm saying. It's just a sketch.
The midpoint of those 2 points.
Would be the
The
center of the circle. Well done. Good. So this is all the knowledge you're going to need to start applying now. Very good.
So you have to use the equation to find the midpoint.
You're spot on there.
Is it x1 plus x2 over 2? I've not done this in a long time. I don't remember. Y1
I'm
plus
so
y2.
glad then that we're doing it, especially if you haven't done it in a long time.
Is that the equation though?
For a midpoint, yeah. So if you have two coordinates, x1, y1, so that's A, oops, and B is given by x2, y2, then the midpoint of AB will be given by x1 plus x2 over 2, and the other coordinate will be given by 1y, y1 plus y2 over 2. Is that a good start?
Yeah, I got -3 over 2 for the first one.
Very good. So the midpoint is -3 over 2 as our x coordinate. And what's the y coordinate?
-9.
That's it. Good. You're still getting, that's it. So some marks there gotten. First mark in there. I might even say 2 marks actually, because you found both the x and the y. So this is 2 marks already done there. Good.
Okay, so then you need to find the equation of a circle. That's a lot of terms. You've got the center point. Isn't that like x minus a?
It's not so bad when you actually break it down a little bit, because the a is the same, isn't it?
Yeah.
So you've only got 1, 2.
Oh, because it's like expanded. It's not like factorial.
Yeah, it's expanded. Yeah.
Okay.
Yeah, exactly.
I thought I was looking at something like, what is that? Okay.
It's intimidating, I know.
Is it like when you put it into the equation of a circle? So it would be like x plus. So you've got the coordinates of the center, right?
Yeah.
So like x plus 3 over 2 bracket. That's in brackets.
And very good. And the key thing here to remember here is that
So
equation of a circle as a starting point is given by x minus a squared plus y minus b squared. And this is always equal to r squared. So the equation of circle is, is x minus a squared, where the center of circle is at A, B.
Yeah. So then if you plug it in to that equation,
Good.
it's x. So x plus 3 over 2.
Good.
So, and then that's squared plus y plus 9 squared. And then you can find the radius by using one of the points, find the distance between them.
Go on then, tell me what the radius is.
But let me work it out.
Cool. Nice one.
Going so fast, wait. Okay, so let's use b because it looks easier. -5. Oh, I got 6.946. I got like a decimal. I don't even know if it's right.
You got a decimal for the radius, but remember that it's, oops, radius squared. It's not just radius squared.
So will it be that number squared? Do you have to find
well,
it?
If I know what this is, let's just take a bit of a moment to break this down. Hey, so the center is -3 over 2 and -9. So if I want to work out the radius, so that is -3 over 2 -9. I know what one of the points is already. So we can use this point, and oh gosh, I should have probably labeled this as end B. Come to think about it.
I got 12.5. I don't even know if that's right.
12.5 for the radius.
Yeah.
Let me just double check that as well. So not square root. You're right, spot on. Spot on. You're spot on. So the radius is 12.5. So you want 12.5 equals radius. So what are you going to do? You're going to square it, aren't you?
Yeah.
Excellent. Keep going.
Oh, do we need to expand it? Oh, we need it in that form.
Unfortunately, yes.
Okay, if you expand the 12, I mean, if you square the 12.5, you get 156.25. 56.25.
156.25. Okay.
Okay. And then you'd have to, to expand these two brackets.
Now look, I'm going to show you a trick when expanding.
You have to complete the form.
Sorry?
Like, do you complete the form?
No, not that trick. No, that's not the trick I've got in mind. I've got another trick. Blank page after current. So if you want to do these really quickly and say you're given something like I'm just going to throw in some random stuff. 4x plus 5k squared. If you want to save time on expanding something like this, instead of foil or whatever it is that they teach.
The binomial expansion thing.
No, not even that. Not even that.
What is it?
This is just a shortcut I realized when I was doing my A levels, and it works, okay, every time. Okay. So maybe I should put my name to it. Yeah. I should be famous, maybe. No, but it's very basic. All you do is the first term, square this first term. So what is 4x squared?
16x squared.
Good. The last term, square this term. What's that term? If you square 5k.
25k squared.
Very good. Now to find the middle term, all you do is you do 2 multiplied by 5k or whatever with the sign and multiply that answer by 4x with the sign. So what's 2 times 5k?
15k.
Nearly there.
Oh, 10k. Oops.
I know, it's been a long day for all of us. 10k. 10k times 4x?
40kx.
Good. So the middle term will be plus 40kx. And you're good to go. Done.
Oh.
All right. Okay. And that will work with anything. Here's another one for you to grapple with. 2z minus 8y. Expand that.
Okay, so you'd get 4z squared.
Good. First term. Last term would be
64 minus 64.
Nearly squared. There. So you've got to square 8y. If you square 8y, what do you get?
Is it not 64?
Yeah, no, you're right. But I thought you said you mentioned a minus. That's why I was a bit. Because if you
square no, I meant to say plus.
Very good, thank you. 64y squared last term. What's your middle term going to be?
Okay, so you got minus 16y.
Good.
Times, is it 2x?
It's a z.
Z, I mean. So you'd get minus 32yz.
Correct, and that's your middle term. And you're off. Now you do this literally, like when you get really good at it, you can do it in 5 seconds. Literally 5 seconds. Square that, boom, 2 times that, boom, done. Literally 5 seconds.
Does it work all the time?
Every single time. And trust me, I've used it through all my A levels, through all my university. So, and I've still taught it. And I've never had one student come to me and say, "So your method doesn't work when the question looks like this." And I've been tutoring for at least 20 years now. So I think it's fair enough to say it works. Okay. So you can expand these in record time, is what I'm trying to tell you. All right.
Okay.
They look
So
horrendous.
for the first one,
Sorry?
oh, are we not going to do it?
We can do it, or we can go to the next question. I can leave you to do this
Okay,
as a bit of a
yeah.
homework piece if you
Yeah,
want
sure.
to. Yeah?
Yeah.
Okay, cool. All right. Okay, I'll leave this as another homework piece because this is dealing with circles again. Number 7, modeling.
Okay, you got displacement. Okay, write down the position vector of the boat. Oh, it's like, isn't there an equation for this? That position vector is like distance.
Absolutely right. And
Displacement add something.
Position vector is given by S plus R naught, or you may see it as R naught. Of course, these are vectors, please note, plus S, where R naught, this here is the initial position. Okay, so that's your first hint. Bless you. So that's your first hint.
Yeah, so we've got the displacement. So it's located. Is the 10, 0 the initial position?
Very good.
Can you write that as a vector?
Oh, certainly, because this is written in XY coordinates. So how can we write this as a vector?
It's like the I is 10.
Good. So 10i.
Yeah.
And what would this be?
0j.
Very good. Excellent. Good start.
So be that add the S.
Correct. Absolutely. Not as horrendous as what you've been doing before. So what do you get?
It's minus 40 sine. Isn't it not just the I's add together?
Yeah, because you've got no J.
Yeah.
Isn't it?
Yeah.
Yeah. So what would that be finally?
Do you have to simplify it, or do you just write it?
You can't simplify it. It's just the 10 adds to the I.
No, okay. Why are you taking a... Oh, never mind.
Okay, that's fine.
Yeah.
Because it's a minus, okay? Good.
Yeah.
Plus 30 minus 30 cos pi t over 900. And of course, this here would be in brackets, or be in brackets, and that would be a J.
So that's the first bit.
That's the first bit done.
Find the distance between the distance the boat is from the mooring point and the distance it is from the origin at the point when t is equal to... Okay, distance is a scalar.
Good.
So you'd have to, at one point, you would have to do the magnitude of S.
Very good. So Pythagoras is going to have to come in.
Yes.
You're spot on. Excellent. You're absolutely smashing it. Good. Pythagoras for that one. Excellent. Right.
Well, I'll just tell you how I'll do it, and then
go on.
So you'd put in t into S, right?
Mm-hmm.
And then you'd just do the thingy of it.
Mm-hmm.
Pythagoras of it, right?
Correct.
Okay.
Correct. You're absolutely right. You're absolutely right. Well done. Good. That neatly brings us then to the close of this session. But I'd like you to have a go at the rest of the question as well. Okay. And also fundamentally, I think I'd really love you to, again, do some circle stuff, the work on circles. All right. And what else? Yeah, some of these as well. I will and I shall send you worked solutions to all these problems as well. so that when you've finished, you can, of course, self-regulate and have a look at the answers and see how well you're getting on with them. Is that okay?
Yeah, that's fine.
Awesome. Rhea, it's been a pleasure and well done today. I really hope that the stress levels calm down a little bit. Okay.
Yeah.
And if they haven't, when I see you on Friday, just let me know and I will try and give you a few more pointers as to just how to manage it. Because it can be a good friend to have a little bit of it. But when it's too much, it really can be detrimental. Okay.
Okay.
Yeah. Well done today. Well done today. And bless you again. Okay. So I'll see you on Friday. What time did we say Friday? Was it 6:30?
I think it was 7.
7. Yeah. Yeah. No problem. So Friday, 7 p.m. Do you have any further questions for me?
I'm just thinking for like further lessons, like what we
Yeah,
could
go
do.
on then. Go on. What you'd is there a topic? I know you've already mentioned trig, so we'll probably cover that over half an hour on Friday. The trig stuff
Yeah.
you mentioned. Is there anything you want to slot in? If you can't think of anything right now, just take a time, go through the problems that as you're doing already anyway, and then you can always drop me an email. But if you know what it is, please feel free to let me know now.
Do you think I should start doing past papers now?
Oh yes, oh yes, oh yes, oh yes, oh yes, oh yes, oh
Okay.
yes.
I do have a lot of them. I just didn't know whether I should have saved it towards the end, but I guess the end is fine.
Yeah, no, I definitely think that if you start doing past papers now, they'll give you a good indicator of which areas you're weak on and you need to focus on. And I know it might be more than one topic, but that's fine. The thing is now you're going to bring something to the table and tell me, right, I want to work on this. Yeah, because this is something I've really been struggling with. So there's no better way to judge, your proficiency within the topics than by doing past papers. And I think at this stage, Rare,
Yeah.
don't focus on doing them in the allocated time. Just focus on let me do the questions. That's what you want to do. Okay.
Okay.
Once you've
Do you have
worked on the,
time for that?
do you have to, sorry?
I mean, like, don't you need to like learn to do it in time
No,
conditions?
I absolutely know you need to learn it in time conditions. But for now, if you want to know what you're good at and what you're not so good at,
Yeah.
don't give yourself a time condition. I'm trying to find all the best ways to not put your brain under so much pressure. Okay.
Okay. Yeah.
So that will be the first phase. Just can I do the questions? Am I comfortable? I want to know what topics I'm not comfortable with without putting a time pressure on yourself. Once
Yeah.
you've done them and I would say for a week, then the
Yeah.
next phase is going to involve, and in that week, you're going to let me know which topics you are finding particularly difficult. So we're going to be
Yeah.
working on them. Then the following week, you now need to go into a timed practice because
Okay.
you'd have made time to work on those areas you're weak on.
Okay.
And now that you feel like, yes, I'm ready, then you start doing them under timed conditions.
Yeah.
Okay.
Yeah.
Yeah, good stuff. Are they electronic, the papers you've got?
No, they're paper copies.
Okay.
I do have electronic copies of them. If you
You do have
want.
electronic copies as well of them. Okay.
It's just our school. They just printed off all the exam papers they could find for us to do.
Okay. Well, if you want to send me any that you're going through, any questions you find particularly difficult, then like I said, I've given you my number. Just WhatsApp me, okay? And just
Yeah.
let me know. So you don't have to wait until we have the next lesson. Like you can literally tell me, look, I'm doing these questions and I found this tough. These are the questions themselves. Next lesson, can we probably cover a little bit on this and can you enlighten me maybe on how to think about this problem? I don't mind doing that. Okay.
Yeah. Okay.
Excellent. Super duper. It's been a pleasure as always. And I look forward to seeing you on Friday. And please keep doing what you're doing and be kind to yourself as well. All right, Rhea.
Okay. Thank you so
You're
much.
welcome. Not a
Bye.
problem. See you soon. Bye now.
Bye.
Okay, bye.